Okay, welcome back. We got 3 more weeks of this. Hopefully everybody's doing well. Hopefully everybody's doing the assignments okay. I know we had probably our lowest a number of assignments turned in, and it's still quite a few, but there's some of you that are having issues. And if you're having an issue with something that I can help with, let me know. If it's something technology wise, let me know, and I will start knocking on doors and getting people involved that can help you out. Okay. Um, with that said, we're going to continue on with our gases, and this is the last thing about gases, and it's called the ideal gas law. And I'm going to talk about the ideal gas law, and I'm going to bring up a presentation here. So this is our usual step is, what's that? Oh. Okay, here it is. Don't call me a boomer. Okay, so hopefully, let me change that. And you can see this screen. This is the ideal gas law. And the ideal gas law is this: PV equals nRT. Now, really quick, when we talk about this equation, and this is kind of small, so I'm gonna give you a nice bigger view of this, so you can read this with me. Here's the big thing: is that PV equals nRT. Pressure can be any units, okay? But we want to try to keep them in kPa for our usage, all right? So if it comes in ATM or millimeters mercury, just convert it to kPa. Volume should always be in liters. Temperature should always be in Kelvin. Remember, Celsius plus 273 gives us Kelvin. And then there's this R, and this R is the ideal gas constant. And there's a couple of them here. I like to use this one, 8.31 liters times kPa over moles times Kelvin. This is just a number. I'll show you. We just put the 8.31 in the equation, so there's no solving going on here with this. And then lastly is moles, and so this little n is moles. So pressure, volume, temperature, ideal gas constant, and then n is moles. And so it's number of moles of the gas that we're talking about. And that's really the one thing that's different. So what we have instead of just pressure, volume, and temperatures, we have moles and a constant. And again, if we keep pressure units in kPa, volume in liters, moles in moles, and temperature in Kelvin, we can use 8.31 as our constant. If we change any of these, we have to use a different constant. So if you Googled ideal gas constant, you would see tons of different examples of different variations where you have a different volume or a different pressure, etc. I've never seen one with degrees Celsius, but there could be one out there. But Kelvin's what we want to keep it at, okay? So for our sanity, we are going to use this one only, okay? The 8.31, and that means volume in liters, pressure in kilopascals, moles, and temperature in Kelvin, okay? So like an example of this would be what pressure is required to contain 0.023 moles of nitrogen gas. So we got moles of 0.023 in a 4.2 liter container. So liters is volume, and then a temperature of 20 degrees Celsius, okay? And that's what we're looking at there, okay? So let's see what that looks like up here. All right, so here's what we got. Our number of moles is 0.023. Our volume is 4.2 liters, and our temperature is 20 degrees Celsius. Now, first step, we got to add 273 to our temperature to get 293 Kelvin, okay? And then our constant R is 8.31. And if it's 8.31, that means our volume has to be in liters. We have to have moles. We have to have Kelvin. And then our pressure answer will be in kPa. So I know this, and this. I just have to solve for this. So I substitute in. I take my P times my volume, which is 4.2, equal my number of moles, which is 0.023, times my R, which is 8.31, and my temperature, which is 293. Okay, Then to solve for P, I divide by 4.2. All right, and then I'm going to get a pressure here. Okay, so I'm going to get your calculator out and do this with me. I take 0.023 and I multiply it by 8.31 and I multiply that by 293 and I hit equal. Then I divide by 4.2 and I hit equal. And what I get is 13.3 kPa. And I know it's kPa because I'm using this constant, and my pressure with 8.31 being my constant is going to be kPa. Okay, so write down what you know, solve for what you don't know. I'm going to give you another example here so that we can solve for another variable, but that's what that's going to look like. So let me present now, and we'll bring that bad boy up. And here's what we got. So we have oxygen gas, and it's being collected at a pressure of 123 kPa. All right, so the first thing we know is we know our pressure is 123 kPa. And it says has a volume of 10 liters. So we know our volume is 10 liters. And what temperature must be maintained on 0.5 moles of this gas in order to maintain this pressure? So I know my N, my number of moles, is 0.5. And then we're looking for temperature. All right. So I'm going to close this one out for you. And we're going to come back to our screen here. And you can see all of this is here. I know my pressure, I know my volume, and I know my number of moles. So I know this, this, and this. This is a constant, so I always know this one's 8.31. I'm going to solve for temperature. So I substitute in 123 kPa is my pressure, 10.0 liters is my volume, my number of moles is 0.500 R, 8.31. Solve for T. All right, now so I do this all as one big calculation. Obviously, if you want to do it separately, please do so. But those cancel. So T is equal to this times this divided by this times this. So how I would solve this on my calculator, if I want to do it as one calculation, if you want to multiply this, and then divide your answers, go right ahead. You'll be fine. But I take 123 times 10. Then I divide by 0.5, and then I divide again by 8.31. And I get a temperature of, it looks like about 296 Kelvin. And again, temperatures in Kelvin in this case, okay? Temperatures in Kelvin in this case. This equation, make sure pressures in kPa, volumes in liters, moles, and temperatures in Kelvin, okay? And R then is always 8.31. So you'll probably never have to solve for R, but just know that that number is 8.31 as long as kPa, L, moles, and Kelvin are all established, okay? Hopefully this is easy for you to do. If you have questions, we have class 4 days this week, okay? So Monday, Tuesday, Wednesday, Friday, 9 and 10 a.m. And then on a Thursday afternoon, there's office hours at 1:30. Those are the best times to reach me. If you show up and there's a lot of people there, or if there's more than one person and you want to have private conversation, I'll just open up another Google Meet. I'll pop you on, and we can get this solved. Okay. 3 weeks. Get outside in the sun as much as possible. Make sure you get your work done. Okay. And again, if you're having issues, man, send me a message. Let me know, and I'll see what I can do to help you. Okay. Hopefully we find you all well, and we'll see you soon.